First, the record. On the evening of August 1, 2007, an 8-lane bridge over the Mississippi River in Minneapolis collapsed in seconds. 13 people were lost, 145 were injured. We keep the camera on the engineering in their memory. This is the I-35W bridge, opened in 1967. 1,907 feet, 8 lanes, a steel deck truss designed by Sverdrup and Parcel to the 1961 ASHO specification. It had 112 nodes, and it was fracture critical. If certain main members failed, there was no second path for the load. At one node, called U10, 5 members meet, the big diagonal carrying compression down from the span and the upper cord it must hand that load to. They do not touch each other. Each is riveted to a pair of flat steel plates that sandwich the joint. Those plates are the connection. If the plate is insufficient, the members are irrelevant. If you would rather understand why things fail than watch them fail, subscribe. A new failure is drawn here every week, each one a reason you are safer than you know. This is one of those plates, photographed in 2003, 4 years before the collapse. Look at the edge. It is not flat. Here is the flaw. Every gusset plate at nodes U4, U10, and L11 was drawn at ½ an inch thick, when the load called for about 1 inch, twice the thickness. The specification also required a free edge that long to be stiffened. At ½ an inch, the limit was 24 inches. U10's edge measured 30. It was not stiffened. It gets worse before anything was added. Later analysis found parts of the U10 plates were already past the steel's yield point under the original 1967 bridge alone. No traffic, no later renovations, just the bridge as first opened. On paper, this connection was never adequate. It simply had not yet been asked for the last increment. And the plate was telling the truth about itself. Bowing at both U10 nodes was documented in photographs in 1999 and again in 2003. But gusset plate distortion was not a condition inspectors were trained to rate, and gusset plates were excluded from load rating calculations entirely. The distortion and the inspection program were looking at different things. Now the load path, and it only grew. In 1977, a concrete overlay added more than 3 million pounds, up 13%. In 1998, new barriers and railings added another 1.1 million pounds, 6% more. Every added pound crossed the diagonal into the ½ plate onto the same unsupported edge. On August 1st, a resurfacing project staged its materials on the 2 closed inner lanes directly over the U10 nodes. Sand, gravel, water, and equipment weighing 578,735 pounds in place by about 2:30 that afternoon. The design inadequacy was the cause. This was the load it finally could not carry. At about 6:05 that evening, the free edge that had been bowing for years lost its fight, and the U10 gusset plate released the diagonal it carried. The truss was non-redundant. There was no second path. One node's failure was the whole span's failure, drawn once. 1,000 feet of deck truss came down. About 456 feet of the main span fell 108 feet into a river 15 feet deep. It happened in seconds. The safety board's finding, inadequate load capacity at U10 from a design error that failed under decades of added weight and that day's construction load together. Contributing, a quality control process that never confirmed the gusset plate calculations were performed, and inadequate design review by federal and state officials. Corrosion, a floor truss fracture, temperature, and pier movement were all considered and ruled out. Here is the finding that stings. The calculation that would have caught a plate at half the needed thickness was never performed and never reviewed. Through design, through approval, through 2 projects that added weight, past photographs of the plate bowing. No step in the system's review process existed whose job was to check whether the connection could carry what it connected. This is the replacement, the St. Anthony Falls Bridge, open a little over a year later. And here is what changed. Every non-redundant steel truss bridge must now have its connections, gusset plates included, checked against the load whenever conditions change. A design quality assurance program catches a missed calculation before the plans are final. Inspectors are trained to look for bowing, and construction loads are checked against what a structure can actually carry. Failure mode, gusset plate failure. A connection built at half the strength its load required, never checked until the day it had to carry everything at once. Nothing breaks without a reason. Now you know this one. Drawing filed. Like and subscribe to support the channel.